So good morning children, welcome to the next class of ray optics. In the previous class we have seen what is the difference between real depth and apparent depth, and the basic formula behind the real depth and apparent depth, and the continuation of that particular class. In today's class we'll be just seeing what is a shift to a through a glass slab. So for this purpose you consider a glass slab of thickness T. Let T be the thickness of the glass slab of refractive index mu, and it is surrounded by a medium air of refractive index mu is equals to 1 here. So here let an object O be placed at some distance from this particular glass slab, and from the position of I we are seeing this particular object. Now what will happen, and if you want to draw the ray diagram, so this is the incident ray coming from air to the glass slab. Let me draw a normal here. As it is moving from the rarer medium to denser medium, instead of moving along the same path, it will bend towards the normal. It will bend like this. It will bend towards the normal here. Yeah. Again let me draw. Again it is coming from the denser medium to rarer medium. So let this be the normal. And instead of moving the same path, it will bend away from the normal like this. Now if you back extend this, and if you back extend this, here this is what called a shift S. As object is at O, and as we are seeing from this particular place, the object seems to be at I2 position. I1 is nothing but refraction, it is due to this refraction at first surface, and I2 is nothing but refraction at a second surface. So I can take out the final image to refraction at the second surface. So this final image is due to this particular ray. So the final image, instead of this place, the object as it is placed here, we people will be seeing the object to be placed at this place. This shift in the image position is called shift, and this is due to the glass slab here. The mathematical formula for shift is given by S is equals to T of 1 by 1 minus mu. This is a formula to calculate the shift in the object's position, and T is the thickness of the glass slab and mu is the refractive index of the glass slab. So there are some points corresponding to this particular shift here. That's nothing but, number one, the rays are paraxial. First. Number two is the medium on the both sides should be same. If the surrounding medium is other than air, then S can be calculated by the formula S is equals to T of 1 minus mu surrounding by mu slab. And one more point should be remembered. This particular shift is independent of the distance of your object placed. As initially we placed an object at a distance of x from the slab, imagine the object distance from the slab will not affect the shift in the object's place or image place, and it purely depends upon thickness of the slab and the refractive index of the slab. So these points you should remember in order to solve these problems. Let me derive this formula. So to derive this formula, consider refraction at first surface. Here light is passing from rarer medium to denser medium. So we need to take N2 as 1 and N1 as mu. N2 as 1 and N1 as mu. Let the distance, object distance d be, real depth be x. So I can use the formula N2 by N1 is equals to d by d dash. Yesterday's formula. So I can write 1 by mu is equals to x by d dash. So I'll be getting d dash is equals to mu x. That is, let this distance mu x. This is I1. Let this be I1. I1 is nothing but the first image due to the refraction at a first surface. Now this I1 will serve as a virtual object for your second surface. So refraction at second surface. Light is passing from denser to rarer. So here N2 is equals to mu, N1 is equals to 1, and D will be, this is T beta and this is mu x, T plus mu x. So use the formula N2 by N1 is equals to D by D dash. Mu by 1 is equals to T plus mu x by d dash. So if I rearrange that, d dash is equals to t plus mu x divided by mu. The position of your I2. I2 is formed at a distance of t plus mu x by mu. Now I want the distance between O and I2. So for that purpose what we need to take is let this point be A. OA is SC is equals to OA minus I2A. OA minus I2A. So this value will be, OA is x plus t minus I2A is so simplifying this I will be getting t of 1 minus 1 by mu. So this is a formula for shift. Shift S is equals to t of 1 minus 1 by mu. So take down question number 1 based on this formula. I have an glass slab of refractive index mu is equals to 1.5. So this is the object place. So from here I am seeing the object. An object is at, remember, 10 centimeters. Object is at 10 centimeters. The thickness of the slab is 15 centimeters. So let this be object O. The question is, an object O is placed at a distance of 10 centimeters from a slab of refractive index 1.5 and thickness 15 centimeters. Then what is a shift seen in the object as seen by the eye here? So find the shift. So simple, and the formula S is equals to T of 1 minus 1 by mu. Here all terms are given in the book, in the problem. T is 15 centimeters, 1 minus 1 by 1.5. If we simplify this, I'll be getting 15 into 0.5 divided by 1.5. So if I just get, I'll be getting 5 centimeters. So S is equals to 5 centimeter. It is a positive value. S is positive. That means the shift is along the direction of incident light. The light is passing from this direction. So light is passing in this direction. The shift also will be in this direction. So it will be somewhere around here. So this I can take as I, and this value is a shift, which is S is equals to 5 centimeters. The same problem we can do, and here the refractive index mu is equals to 1, and here also the refractive index mu is equals to 1. In that particular case we will be getting 5 centimeters. The same problem if you take in some other type, something like what do you say, the same problem, you take a glass slab, an object is placed at same 10 centimeters, O object, and from here I am seeing the object. This is the position of I. The T is again 15 centimeters, and mu is equals to take as 1.5, but here mu is 2 and here also mu is 2. Now what is the problem? What is the formula? This is question number 2 you can take. So find the shift in the object as seen from the eye. Now S is equals to T of 1 minus 1 by mu. Can this be used? Can I use this formula? No, because the surrounding medium is not air. So if it is other than air, the formula will be S is equals to T of 1 minus mu surrounding by mu slab. Now you need to use this formula. So we'll be getting S is equals to T as a 15, 1 minus 2 by 1.5. So this will be around 15 into minus 0.5 divided by 1.5. If I simplify, I will be getting minus 5 centimeters. The negative meaning. Earlier in the previous problem we got positive value where we have taken the shift is towards this side, towards the slab. But here the negative value indicate the shift is away from the slab. So here the position I can take the image, and this is a shift value which is equals to minus 5 centimeters. So let me take the third problem. Question number 3, if you take a slab 1, a slab 2, slab 3. Here it is mu is equals to 1.5. The thickness is 30 centimeters. And here the mu is equals to 2 and the thickness is 20 centimeters. And here the mu is equals to 1.5. Thickness is around 10 centimeters, or sorry, 15 centimeters. And the gap here, consider this as 10 centimeters and this also has 10 centimeters. And this is air, and this is also air, and this is also air. And we are seeing the object from this place. From that particular eye position, I am seeing an object placed at this place O, which is at 40 centimeters. So this problem we can do in 2 to 3 methods. First method is to draw the ray diagram. First surface, second surface, third surface, fourth surface, fifth surface and sixth surface. Using n2 by n1 is equals to d by d dash for all the 6 surfaces, and we'll summing up, we'll be getting the answer. And another formula is simply S1 plus S2 plus S3. As we are having 3 slabs, we can calculate S1, S2, S3 separately and we can add them separately. Remember, the shift, the final shift is independent of the medium present in between the slabs. Condition is here and here it should be air or else same medium. And it is independent of the distance between the slabs. Between the slabs, I am saying between the slabs. So calculating S1, S2, S3, if you want to calculate S1, formula is T of 1 minus 1 by mu. T is how much here? 30. 1 by mu is 1.5. How much will you get? Simplifying, you will be getting this as 10 centimeters. See, 1.5 LCM, and we'll be getting 1.5 minus 1, 0.5 by 1.5. So if you simplify, you'll be getting 10 centimeters. Similarly, S2, T of 1 minus 1 by mu again. Your T is how much? 20 of 1 minus 1 by 2. 1 minus 1 by 2 is again 1 by 2. 1 by 2 into 20 is again 10 centimeters. So shift 3. Again same formula, T of 1 minus 1 by mu. T is how much here? 15 of 1 minus 1 by 1.5. So simplifying, you will be getting 5 centimeters. All are positive values. So net shift will be SN will be equal to 10 plus 10 plus 5, 25 centimeters. So it will be somewhere around here, the final position, which is 25 centimeters from the first block. Imagine you have imagine an object which is at 25 centimeters from the glass slab of thickness 15 centimeters and of refractive index 1.5, and here I have a concave mirror of focal length 40 centimeters placed at a distance of 25 centimeters from the second surface, and here it is air, and here also it is air. Means air means the mu will be 1, and here also mu will be 1. Now I need to calculate what is the distance between, find out the distance between the final image and the mirror. So some options are there. Option A is around 100 centimeters, option B around 120 centimeters, option C is around 125 centimeters, and option D is 115 centimeters. How to do this problem? So let this be the surface 1 and this be the surface 2, and we have another concept of mirror here. So we need to calculate a separate shift for first one and second one and the mirror. So here for the first surface, if I want to calculate, here S is equals to T of 1 minus 1 by mu. As it is surrounded by air, I can use this formula. So T is how much here? 15 centimeters. 1 minus 1 by 1.5. Simplifying, I'll be getting 5 centimeters. Means it is positive. So it will be shifted 5 centimeters towards this side. This is the shift here. Let this be the I1 value. This is not the final image. This is only first image here. Refraction at first surface. Now what will happen? As there is a shift of 5 centimeters, the ray will be coming from this I1 to the mirror. So as the ray is coming from I1 to the mirror, this will be the object distance. U will be how much? 25 plus 15, 40, and here it is 20. As already it is advanced to 5 centimeters, so I need to subtract 5 from the 25. So this will be around 60 centimeters. So from mirror, I have U is equals to minus 60 and F is given here. As it is concave mirror, focal length is minus. I need to calculate the image distance V. UF by U minus F. By arranging the mirror's formula, I will be getting this one. So I can take minus 60 into minus 40 divided by minus 60 minus of minus plus 40. So it is around 2400 divided by minus 20. So minus 120 centimeters. So I have an option 120 centimeters, but that is not the right option, because if the image fall between the mirror and the slab, that will be the answer I can take out. If the answer is less than 25 centimeters, suppose if the answer I have got as 20 centimeters, I can mark as 20 centimeters now. but what happened is the reflected ray has to fall at this point somewhere around this is 60, so 60 and 60, this is 120 centimeters, but the reflected ray has to pass from the glass slab. Again there will be a shift in the final image. The shift in the final image can be calculated again using the formula SC is equals to T of 1 minus 1 by mu. So here again T is same thickness, that is 15 centimeters of 1 minus 1 by 1.5. So solving this, I will be getting around 5 centimeters. Again it is positive. So positive means not this side, because the ray is reflected, it is coming along this direction. For this direction positive means it will be around this part. So this is a 5 centimeters value. So now, so from here it is 5 centimeter towards this point, sorry. So extra 5 centimeters it has moved from this point. So 120 plus 5. The final shift in the position is 120 plus 5, that is 125 centimeters. So option C. Thank you.